In this video, we're going to talk about how to identify key features of quadratic functions in conic form. So, did you know that a parabolic mirror is actually used to light the Olympic torch using the sun's rays without the use of matches or lighters? This method was inspired by the ceremony that was used to light the torch in ancient Greece. And so, what happens is the parabolic shape of the mirror causes the sun's rays to focus on a single point. So, here's like a diagram representing the parabolic mirror. And then, when this rays of sunlight all come in, they actually get focused on this point right here that's called the focus. And what will happen is this point will become so hot because of all the rays being focused that when this gas torch is held up right at that point, the Olympic flame is lit. And it actually doesn't require any matches or lighters because that point is just hot enough to ignite that flame. So, this leads us to the definition of a parabola. A parabola is actually defined as the set of all points x, y that are the same distance from a given point, which is the focus, and a given line called the directrix. So, this focus is that point that we were talking about that they use to light the flame. So what happens is if I take a point xy on my parabola and I measure the distance d to the focus, it's actually going to be the same as the distance d to a line that's drawn here, and that line is called the directrix. And so every point that has this quality will actually define the parabola. So the focus will be located on the axis of symmetry. The distance from the focus to the vertex will be same as the distance from the vertex to the directrix. So the directrix will be a horizontal or vertical line that is perpendicular to the axis of symmetry. And whether the directrix is horizontal or vertical is going to depend on whether the parabola is horizontal or vertical. So what we can do is talk about conic form of a parabola. So a parabola is a type of equation that's known as a conic section because it's actually formed by the intersection of a plane and a cone as shown in this diagram. So you can see here if this orange plane intersects with this cone, that parabola is the shape that's formed right there in that cross section. So that's why a parabola is known as a conic section. So that leads us to conic form of a vertical parabola. So this is a new type of equation that we learn in Algebra 2. We can write the equation of a vertical parabola as x minus h squared equals 4p times y minus k. And once again, this equation is going to tell us a lot about the key features of the parabola. If p is positive, p is greater than 0, the parabola will open up. If p is negative, p is less than 0, the parabola will open down. The vertex will be located at HK, and here we have to be careful because H and K will both have the opposite signs because both H and K are being subtracted in the equation. So we'll have to switch the signs of both when writing the coordinates of the vertex. The equation of the axis of symmetry will be x equals H because remember the axis of symmetry passes through the vertex. The absolute value of P will tell us the distance from the vertex to the directrix or from the vertex to the focus. Because remember, those two distances are the same based on the definition of a parabola. So remember, just to once again, be careful when determining the coordinates of the vertex. Conic form involves x minus h and y minus k, so we have to switch the sign on both coordinates when determining the vertex. So for example, the vertex of x minus 2 squared equals 12 times y plus 1 will be 2, negative 1, the opposite signs of what we see in the equation. The vertex of x plus 4 squared equals 4 times y minus 5 will be negative 4, 5 because those both signs are opposite of what's in the equation. So when we determine the focus and the directrix of vertical parabolas, it's going to depend on the parabola's direction of opening. Because you see, if the parabola opens up, the focus is going to be here, right? It's going to be within like the parabola, and the directrix is going to be on the outside. So we're going to use these formulas to determine the focus and the directrix. If we do h, will stay the same because you can see that the vertex and the focus will have the same x coordinate, but then we're going to add that value of p to the y coordinate so that we get this focus right here. The directrix, remember, is also going to be p units away from the vertex. So what we're going to do is we're going to say y equals k minus p because the directrix has to be this horizontal line. So it has a y equals equation. And then it's p units away from the vertex. So that's how we get k minus p. If it opens down, you can see the directrix is going to be up here because the directrix is always on the outside of the parabola. The focus is going to be on the inside, so this is going to be where the focus is located for the parabola that opens down. We can still use the same formulas because when we have p as negative, it'll automatically adjust because, for example, when we plug it into this equation, we'll get k minus p. But since p is negative, that will, make it positive, and so that's how the directrix will be above. So once again, here are a summary of the key features of the vertical parabola in conic form that we can identify. We can figure out the direction of opening, the vertex, the focus, the location of the directrix, and the equation of the axis of symmetry. So what we're going to do, as we usually do, is start off by identifying the values from the equation. So if you take a minute to write down P, H, and K, it's going to really help you identify these key features. Then we'll use this table to help us figure this out, and then we can verify our answers using Desmos. So let's identify the key characteristics of this parabola. So we know that this equation has the form x minus h squared equals 4p times y minus k. So this value of negative 8 is actually telling us the value of 4p. So 4p equals negative 8. So what we can do to find p is divide both sides by 4. So we're going to get p equals negative 2. So p equals negative 2, and then h and k, remember, will have the opposite sign of what's written in the equation. So h is negative 1 and k is going to be 3. Since p is negative, this is going to open downwards. The vertex will be at hk, so that's negative 1, 3. And then to figure out the focus, we're going to use this idea of h and then k plus p. So the value of h we already know is negative 1, and then k is 3, and then we have plus p, which is negative 2. So that's going to be negative 1, and then 3 plus negative 2, which is 1. So the directrix is going to be y equals k minus p. So that's going to be y equals the value of k, which is 3, and then minus p, so minus negative 2. Minus negative will turn into a plus, so 3 plus 2 will be 5. So we have y equals 5. The axis of symmetry is going to pass through the vertex, so the x-coordinate of the vertex tells us the axis of symmetry. So that's going to be x equals negative 1. So remember, we can always use graphing and Desmos to verify everything that we've just figured out. So we have x plus 1 squared equals negative 8 times y minus 3. So if we click on the vertex, it tells us the coordinates. It's at negative 1, 3. We can see that this parabola does open down. We can also see that the focus is inside the parabola and the directrix is on the opposite side if we do y equals 5. If we type in the axis of symmetry, x equals negative 1, we can see that it does cut our parabola in half. Okay, so here's all the information that we just found. So now let's identify the key characteristics of this parabola. So remember, this 16 is telling me 4p. So I have 4p equals 16. So I'm going to divide both sides by 4. When I divide both sides by 4, I get p equals 4 that I'm going to write here. The value of h is going to be 3. And you may be wondering what the value of k is. Well, the thing to realize here is that I can rewrite this as x minus 3 squared equals 16 times y minus 0, right? It's kind of like there's a 0 there with y. So that's going to tell me the value of k. So my k is actually going to be 0. And so based on p, I would say that the direction of opening is going to be up. HK tells me the vertex, so the vertex of this parabola will be at 3, 0. So to find the focus, I'm going to use h comma k plus p. So in this case, that's going to be 3 and then 0 plus 4. So the focus will be at 3, 4. And then the equation of the directrix will be y equals k, which is 0, minus p, which is 4. So 0 minus 4 is going to give me y equals negative 4. The axis of symmetry will pass through the vertex, so the axis of symmetry will be x equals 3. Let's go ahead and graph this in Desmos and see that we've found all the correct information. So I'm going to start off with my equation. So I have x minus 3 squared, and that equals 16y. Okay, so if I click on this point, it tells me the vertex at 3, 0, and then I can see that 3, 4 is the focus. My directrix is at y equals negative 4. You can see that's on the outside of the parabola. And then the axis of symmetry will be x equals 3. Okay, so here is the parabola. Just going to zoom out a little so you can see it better. So now you can go ahead and pause the video and try doing this example on your own. So here, based on this equation, we can say that p is -5 because we do -20 divided by 4 and get -5. H and k will have the opposite signs, so we have -2 and 5. Since p is negative, this will open down. The vertex will be at hk, so -2, 5. The focus, we will just rewrite the value of h and then do k plus p. So k is 5, k plus p will be 5 plus -5, so that's how we get 0. The directrix will be y equals 10 because remember we do y equals k, which is 5, and then minus p, so minus -5. Well, minus negative turns into a plus. That's how we get y equals 10. The axis of symmetry will pass through the vertex, so that's how we get x equals -2. Remember that we can always verify all of this information in Desmos. So I'm going to go ahead and type in x plus 2 squared, and then we have that is equal to -20 times y minus 5. So you can see here, if we click on the vertex, it is at -2, 5. The focus is at -2, 0. The parabola does open down like we found. The directrix will be at y equals 10. And the axis of symmetry we can see is at x equals -2. So we can see all the information here on our parabola. So we can also graph horizontal parabolas in conic form. Once again, we can identify the key characteristics from the equation. If p is positive, the parabola will open right. If p is negative, the parabola will open left. The vertex will be located at hk, and once again, we have to be careful because h and k will have the opposite signs of what's in the equation. The equation of the axis of symmetry will be y equals k, and then the absolute value of p will once again tell us the distance from the vertex to the directrix or from the vertex to the focus. So once again, remember to be careful when determining the coordinates of the vertex. Since we have x minus h and y minus k in our equation again, we have to switch the signs when determining both coordinates of the vertex. So the vertex of y minus 1 squared equals 12 times x plus 5 will be -5, 1, because h has the opposite sign and k has the opposite sign. The vertex of y plus 4 squared equals 4 times x minus 3 will be 3, -4, because h has the opposite sign and k has the opposite sign. So when we determine the focus and the directrix of a horizontal parabola, it's going to look a little different because we're going to be changing the x coordinate this time, right? Because the focus needs to be inside the parabola. So if the parabola opens right, you can see that we're going to add p to the focus, and that's going to put the focus right here, right at h plus p and then k. The directrix is going to be on the outside, so we're actually going to find the x equals equation, right? Because the directrix will now be a vertical line, and then we're going to do h minus p, and that's going to put the directrix right outside the parabola. Okay, same idea if it opens left. We can still use the same formulas because the sign of p will automatically adjust. So the focus will be h plus p and then k, and the directrix will be x equals h minus p. So here's all the information we can get from a horizontal parabola in conic form. We can determine the direction of opening, the vertex, the location of the focus, the equation of the directrix, and the equation of the axis of symmetry. So when we do this, we're once again going to start off by identifying the values of p, h, and k from an equation, which is going to be a good practice to get in the habit of doing. And then we can figure out these values using the table that we have here and then verify our answers using Desmos. So let's start off with this example. So once again, this is going to be y minus k squared equals 4p times x minus h. So that 4p is going to be equal to that -8 that we see. So we'll actually have to do a little bit of solving to figure out the value of p. So we divide both sides by 4 and we get p equals -2. So P will be -2, and remember H and K will have the opposite sign of what we see. So H will be 1 and K will be -2. Since P is negative, this parabola is going to open left. The vertex will be located at HK, so that's going to be 1, -2. The focus, well, we can use H plus P K to figure out the focus. So h we said is 1, and then p is -2. So we have 1 plus -2, and then k, which is -2. 1 plus -2 is -1, so we have -1, -2. So now let's figure out the location of the directrix. The directrix is going to be x equals h minus p, so we have x equals h, which is 1, minus p, so minus -2. Minus negative will turn into a plus, and 1 plus 2 is equal to 3. So we have x equals 3, and then the axis of symmetry, remember, well, that will be a y equals line, and it'll be y equals k. So we have y equals -2. So let's go now to Desmos and verify all of the information that we've just found. So we have our equation y plus 2 squared equals -8 times x minus 1. Okay, so we can see that this parabola does open to the left, like we figured out. If we click on the vertex, we can see that the vertex is located at 1, -2, like we found. The focus will be at -1, -2. And then if we draw in the directrix, we have x equals 3, and you can see that is on the outside of my parabola. If I write in the axis of symmetry, y equals -2, you can see that we now have all of our information about our parabola. So now let's identify the key characteristics of the parabola represented by y squared equals 4 times x minus 3. So once again, this 4 is going to represent 4p. So we have 4 equals 4p. So we can divide both sides by 4 to solve for p. Well, that's going to give us 1 equals p. So p is 1. And then remember, h is going to have the opposite sign. So h is going to be 3. Well, what's the value of k? We just have a y squared, but remember I can write that as y minus 0 squared, and that equals 4 times x minus 3. So the value of k is actually going to be 0. So the direction of opening is actually going to be to the right. Since p is positive, the vertex will be located at 3, 0. And then let's figure out the focus. So the focus is going to be h plus p. So we have 3 plus 1, and then k. So k in this case is 0. Well, 3 plus 1 is 4, so we have 4, 0 for our focus. The directrix will be at x equals h, which is 3, and then minus p, which is 1. So 3 minus 1 is going to equal 2. So the directrix will be x equals 2, and then the axis of symmetry will be y equals k, which is y equals 0. So let's go ahead and graph our parabola and verify all of the information that we just found. So we have y squared, and that equals 4 times x minus 3. So you can see that this parabola does open to the right like we found. If we click on the vertex, you can see that it is at 3, 0. So if we do 4, 0, we can see the focus. And so if you zoom in a little, I know it looks like it's on the parabola, but that's because we're zoomed out. So you can see that it is inside our parabola. If I type in the directrix, x equals 2, you can see that it's on the outside of my parabola. And then if I do y equals 0, which is basically the x-axis, you can see that that is my axis of symmetry, right? Because this parabola is actually symmetric with respect to the x-axis. So now you can go ahead and pause the video and try doing this example on your own. So here you can see that P is going to be 4 because we have 4P equals 16. So P is 4, and then H and K will have the opposite sign. So we have 2, 4 for H and K. So this parabola, since P is positive, is going to open to the right. The vertex is going to be at 2, 4, and then the focus we can find by adding P to the value of H. So that's going to give us 2 plus 4, and then the value of K. So 2 plus 4 is how we get 6. So we have 6, 4. The directrix is going to be x equals, and then we have h minus p. So 2 minus 4 is how we get that -2. The axis of symmetry will be at y equals k, which in this case is y equals 4. Once again, we can always use Desmos to verify our answers. So we can do y minus 4 squared and then say that equals 16 times x minus 2. Okay, so you can see here's our parabola. It does open to the right, like we said. If we click on the vertex, you can see that it is at 2, 4. The focus will be at 6, 4. And then the directrix will be x equals -2. You can see that is on the outside of that parabola. And then if we do the axis of symmetry, you can see that y equals 4 does divide this parabola in half. Okay, so there's all the information about this parabola. So equations of vertical and horizontal parabolas can be written in conic form. Remember to identify the values of p, h, and k, and then use these values to identify the key features of parabolas.